I believe the recording has begun. All right. Welcome, guys. Well, good morning. Let me close the Zoom chat. All right. How's everyone feeling this morning? Good.
Feeling great.
Cool. Feel free, like I said, guys, this is an interactive lecture. We do want you guys going ahead. When I ask questions, feel free to answer them. Make sure you're aware of whether you're muted or unmuted. And we're going to go from there. We're going to kind of pick up where we left off, throw out some topics there, do kind of a gross overview, build a couple very small projects, and kind of get you guys rolling. The focus of today is going to be classes, objects, object-oriented programming principles, kind of the basics of C# and what it's built around and what we can do with it. So that being said, let's go ahead and kick things off. Welcome, guys. Quick overview of what we're going to talk about today. Like we just said, we're going to do a lot of basic C# principles, stuff like that. We're going to start with arrays and loops, and then we're going to move on to classes and inheritance. And classes and inheritance, if I'm going to be honest with you, is going to dominate the majority of our morning, guys. It's a huge concept. You guys are in the C# track, which means you're looking at moving into .NET. You guys are going to be working with classes, inheritances, objects for the rest of your career, so we want to get a great foundation going now. We are going to talk conceptually a little bit about design patterns. I wanted to discuss LINQ. We probably won't go into it too much because it is kind of a very niche topic. We will discuss unit tests at a conceptual level, and we will also discuss algorithms at a conceptual level. Is that cool with everyone so far?
Yeah, sounds good.
Cool. Well, let's go ahead and kick things off and get started with arrays. So what do we already know about arrays? Who can tell me one fact that they know about arrays?
They're zero-based.
Dig into that. They're zero-based. What do you mean by that?
They have a zero-base index, rather. I'm sorry.
Yes. Okay. All right. Very good. Theo, what's something you know about arrays?
From what I know about arrays, they're easy to use in chars, characters. You can change certain elements of, I don't know, string or whatever.
Okay, so you've interacted with character arrays, maybe use the string iteration method split and split a string into its corresponding character array? Okay.
Right.
Nilesh, what about yourself?
I will pretty much whatever all the others have said, pretty much.
Okay. All right, well, let's dig into the discussion of arrays a little bit here, guys. So we're going to have a couple moments that I always refer to as moments where we're going to read a programming definition. And this will happen often when you guys are searching online, right? You're going to read a programming definition, and that definition is going to not clarify anything for you. We have to learn as developers how to sift through that, right? What information we need and how can we translate that into something meaningful for us? So we get to those moments, which are what are you trying to say? We're going to really dig in deep. And so as a gross overview, an array is defined as a collection which supports efficient storage and manipulation of data. Great, right? That's awesome. What really is an array? An array is a grouping of like things, right? It's a collection of like things that has very specific attributes about it. For what we want to talk about, the big one in C# is it's unlike JavaScript arrays. C# arrays are of fixed size. So at the time of array declaration, that array is so many units big. It can only contain so many units. We can never change that size during that array's existence. That array will be of that size. An array being a core construct of C# does have pre-built methods, so different things you can do with it, just like string. Just like string has split, arrays have different things you can do with them. And there are also different properties that live on that array, help define that array, such as length, that we'll dig into. We're going to focus on single-dimensional arrays. We're going to keep it a little high level for our 1 hour time frame here. However, there are also multi-dimensional arrays in which elements live at X, Y position. And there are also jagged arrays, which can be arrays of arrays, and so on. And Theo, did you have a question? Nope. Okay. I didn't know if it was the hand raising. And feel free, if you have a question to answer. I can tell you we'll probably get back to most of your questions towards the end. So now that we have a gross overview of arrays, let's go ahead and build one. So here I have a basic C# console application spun up. I would encourage each and every one of you guys during these lecture times to have an application, to have an application in the background so that you can be testing and typing along with your instructor. So in C#, we're going to use basic console applications. If you were working in JavaScript or the environment of the web, you'd have a basic web setup. Angular, build a basic Angular client, have it sitting in the background, so on and so forth. So does everyone understand what we got going on here so far? Are there any questions about this?
No, I'm good to go.
All right, Rick's good. Theo and Nilesh, you guys good with the basic setup? Good. Theo's good. I got a big thumbs up. I dig it. And then notice in our Solution Explorer, pretty simple application, pretty simple file stack, right? Not a ton going on. Our program supports a program class with the entry point static void main, which takes any number of arguments as a string array called args, and then runs some logic. Now we all understand why on line 15 I have the console read line. Yes? Does anyone not understand why that's there?
That's there so your program window will pause before it executes everything.
Yes, it'll wait to read my input, which means I can see everything that's happened up until that point. We know that C# is very, very direct. There's not a lot of implied logic going on. Your application will do exactly what you tell it to do. And if you tell it to write something to the console, it will write it to the console, but then when it is done, it will exit. So if we go ahead and run this using the F5 quick key, we should pull up a console. And I do want to verify that you guys can see my console. It did pull up. It's not blocked by any protection software.
Yeah, it's there, man.
Okay, cool. So we get our simple message. Very good. So let's go ahead and declare our first array. So have you guys I'm sure have been declaring variables using the var keyword. Is that fair to say?
Not always. It just depends.
It depends on what?
Well, the var seems more like of a dynamic declaration.
Mm-hmm.
Whereas, like, if you wanted to declare an integer array, you would use int with 2 brackets.
Yes.
Or string with 2 brackets.
Yes, for a string array. Very good. There is multiple ways to do that, and there are arguments for both. Right? There are several arguments for use the var keyword because you might not need to know, especially if you're accessing an outside system, getting information you might not be aware of. You're just passing it along and manipulating it. You might not need to know what it is. However, you might feel that you need to know. You need to lock this memory allocation down to a specific type for your usage. So both are perfectly valid. Feel free to use whichever makes you more comfortable. I am a data type declaration guy, but I am going to try to stick to var for the ease of this lesson.
Right. One quick question. Memory implications. Is it more efficient as far as like garbage collection and whatnot to use to predefine it versus using the var?
I'm not sure off the top of my head, but if you want to reach out to me afterwards, I can read a couple articles and see what I can come up with.
Yeah, I'm sure I could. I just thought I'd throw it out there. I'll let you know.
That's perfectly fine, but I'm not sure of that one off the top of my head, to be honest with you.
Okay.
And are you looking for memory allocation?
Just performance issues, like if you use a whole application full of vars instead of, predefining their types, is it gonna, increase the overhead, stuff like that?
Right.
No worries.
shouldn't, but
Okay.
I mean,
Because it implicitly infers once you.
right. And that's
Okay.
that's when it's allocated anyway.
Yeah.
Yeah, let's table that and feel free to reach out to me. I'll read up on it and see what I can find.
Yeah, cool. I appreciate that.
All right, so let's create an array of numbers. So we want to name our variable appropriately. We'll say var nums equals, and I believe the syntax is new int array 1, 2, 3, 4. Very cool. We have created an array of 4 elements called nums. Just like any other variable, if I wanted to access the information at that variable, I would access it by name. But we're going to notice something here. Again, C#, very, very direct. So if we run this application, we're not going to get something nice and clean. We're going to get what nums is. And if we look at the value of nums, the value of nums is an integer array. So the result that's logged is an integer array. It's not the values within the integer array. That's pretty easy to conceive now, but you guys need to understand that everything referenced by its name, and as simple to say as it is exactly what you declared it to be. There's no implicit logic here. If we want each element in there, we have to dig in. We know we can dig into arrays and grab an element at a given position by, instead of saying nums, as it was pointed out to us, it's 0 indexed. So starting at 0, we can pick the index of an element. If we want the number 3, the index would be 2. So console write line, our array at position 2 would give us the data stored at that position. How would I get the number 1? How would I get the number 1 here?
You'd use 0.
Yeah, I'd say nums at position 0. So very cool. We can add to an array. I told you guys, I started that arrays are of fixed size, right?
That's right.
So what is our maximum index position here? What's the largest index position in our nums array currently?
The max for a 32-bit integer.
No, what is the maximum that we currently have in our array?
We have 4 elements.
So what's the maximum index? What's the largest index present in our nums array?
3 would be the largest index.
Deal. Very good, guys. 3. So let's try to assign value after 3. So let's say nums at index position 4 equals 6. And let's run this application. Let's see what happens. And oh, we're actually going to crash. And let me drag this up here to be seen a little bit. We're going to crash. And we're going to throw our first exception of the day. We threw an index out of range exception. An index out of range exception says, hey, we went to access an index on our array that is out of the range of our declared array. Because that array is of a fixed size, its maximum index is 3. When we attempt to access an index outside of that range 0 to 3, the program does not know how to handle that and it crashes. It throws specifically an argument out of range exception. Right? So arrays are of fixed size. It's something that we need to know. If we ever want to use an array, we need to know that they are of fixed size. Oh, stop. Stop. There we go. All right. So very cool. We have basic arrays. We have basic elements. Guys, go ahead and pull up a console application real quick. And I want you to create an array which contains the names of all of your immediate family members. So go ahead and open up a new console application, and we're going to put the timer on. I'm only going to give you about 2 minutes. You don't need much time to do this. Go ahead and create an array that contains all of your immediate family members first. Let's just do first names. All right, guys, go ahead. I'm going to do the exact same thing. So I'm going to say,
I got a question for you.
yes.
Like when I just declared an array, I just put string with the brackets, family is equal to, and then the the other type of braces, without using new string.
Well, do you want to show us your logic?
Well, I mean, I understand what you're doing. It's the difference between using var and just string with the variable name. I guess it goes back to what we were talking about earlier. No big. I understand both ways.
Okay.
I think what you're doing is more proper than.
There are multiple ways to, as they say, there's multiple ways to skin a cat, right?
Skin a cat. Yeah. Sorry about that.
So good. How's everyone's array coming? Are we good?
It's looking good.
Theo, you're shaking your head at me.
I have an error. It said build errors or something like that when I try to run that.
So let's go ahead and have you share your screen.
Okay, one moment.
I believe I have to stop sharing mine. And then if you go to your Zoom panel, you can go ahead and select share screen, and yours should pop up and fill our Zoom panel. Very cool. So let's break down this code word for word, right?
Mm-hmm.
So we know our basic layout. We have our using statement, which includes our system namespace. We have a namespace that our project exists in. We have our program class, our main method, and then finally we have our array declaration. So we have var names. You want to call your array names, which is awesome. Then you have the assignment portion. And the assignment portion says you want a new int array. Well, what data type, Theo, is your name?
It's a string.
Yeah, it's a string. Right now, you're declaring an array of type integer, so you want an array of numbers. Yeah. And then finally, how do we dictate that something is a string in C#? How do we declare a string? What's the syntax for that? Nilesh, what's the syntax for declaring a string in C#? Hello?
Was that for me?
That was for Nilesh or anyone? Nilesh, what's the syntax for declaring a string? What do we need? What are we missing down here in our array declaration?
Where the
Not quite. What we need.
Want me to answer this?
Feel free.
All right, you're declaring a string, but what you're doing here is you're using variables. To declare a string, you're going to have to use the double quotes.
Yeah, when we want to declare a string, we put the information we want to be that string in our double quotes. Very good. But let's think, Theo. Each one of those things is its own string.
Got it.
Yep, separated by commas. So
see, it's those simple things that get me.
yep, small syntax. right? Each one of those things is its own string. Very good. All right, good job, guys. Very, very good. I'm going to take screen share back from you. All right, guys, can we go ahead and see my application again? Yes, yes, yes.
Yes.
All right.
Okay.
So we got a quick overview of arrays, but arrays are collections, guys. We often want to evaluate each item within that collection. We're going to focus on doing that in an iterative manner, and to iterate over a collection, we are going to need a loop. Who's familiar with loops? Who's worked with some kind of loops before?
I've worked with many.
I struggle with them.
Theo struggles with them. Rick's worked with many. Nilesh, how familiar are you with loops?
There's 4 that I know off the top of my head.
Good, good, good. So we're going to focus on the different types of loops. We're going to mainly focus on a for loop, but there are different types of loops. There's a for loop, a while loop, a do while loop, and a for each loop. Let's break them down. A for loop performs some action over some counter condition and then increments that counter. A while loop evaluates a condition. So while condition is true, performs some action. A do while loop does some action and then evaluates the condition, and we'll break that down in just a second. And then a for each loop says, for each element of given data type in a collection, perform some action. So let's focus on the difference between a while loop and a do while loop quickly. A while loop will evaluate a condition first. So if a while loop evaluates a condition to false, it will never perform its action. However, a do while loop will perform its action at least one time before evaluating a given condition. So a do while loop will always execute at least once, while a while loop may never execute. There's a couple cool keywords in our loops, and you guys should have gotten this with control flow and other information. Break is a keyword just like in our switch statements. Break is a keyword that allows us to exit the loop. The continue keyword allows us to exit the current iteration and move on to the next iteration of a loop. And then I keep using this phrase iteration. Loops are iterative, right? They don't point to anything specifically. They iterate through a data set. So if I have a collection of 5 million items and I look through that collection for an item, that loop is going to look at every element of that collection unless I include a break statement.
I haven't used the, oh, I'm sorry. I haven't used the continue statement that much.
It's not the most used thing in the entire world. There are other ways that we do things. You know, link is common for iterating, and they're not for iterating, for searching and everything.
Yeah.
It's good to know, right?
Right.
At a time.
That's true.
And we also need to know that loops can be infinite. If we make a mistake, our loop is going to run until the computer doesn't, right?
Mm-hmm.
We can perform some action until the end of time. It's a common accident that happens when first starting with loops. So let's switch back. Let's pop back to our application with our names here. And what if I wanted to log each person's name? So I got a pretty big family, and I'm trying to think. I would make sure I didn't leave anyone out, so nobody watches this video and ostracizes me. But we want to loop through this collection. What I want is I want to display each name on the screen. Well, I could write the statement console.writeLine span at position 0, and then I could do that at position 1, and so on and so forth, right? I can do that all the way for every name in my collection. However, that violates a huge principle. Who knows what principle that violates?
That would be the dry principle.
Yeah, it violates our dry principle. Don't repeat yourself, right?
Do not repeat yourself.
Do not repeat yourself. Very good. So to iterate through this collection, let's use a basic for loop. And trying to remember for loop syntax is going to be very fun. So first we need to declare the iterator variable. So for var I, and set its value to the beginning or where we want to start the iteration. Well, if we want to iterate over every element of the array, we want to start at position 0. Is that fair?
Yep.
Now we need to contain our loop. We said that loops can be infinite, right? And we don't want them to go on forever. So we got to contain this loop. You got to say we want to do this logic as long as I is less than fam.length. This is our first opportunity to take a look at a property that lives on an array. The length property tells you the length of the array. Well, it doesn't tell you the index. The index versus the length of this array. The length of this array is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 is the length of this array. However, the maximum index is 9. So we want to look at all indexes that are less than 10, and all numbers that are less than 10 are theoretically 0 through 9, not including negatives. And then finally, after each pass through the array, we have to increment our iteration, I++. Too much JavaScript this week. All right, guys. So far, so good. Let's go ahead and perform our logic. Well, I said I wanted to console log all the names in this array. Or console write line.
Console write. You're on JavaScript.
I am. So I want to console write, and I know I want to console write from this array, and I'm going to go at position I. As we talked about, I begins at 0. So the first iteration of this loop, the value of I is 0. It logs this name. Then we perform some logic. We check and make sure that I is less than the length of this array. Well, guys, is 0 less than 10?
Yep.
Yep. So we increment I and go again. So now I equals 1. Position 1 would be David, Molly, so on and so forth, right? And if we run this application, provided I didn't supply any bad code, we should get a console output of every name. Boom.
Fantastic.
Awesome. So guys, there are other types of loops that do other things. I encourage you guys to check them out. You need to know them. You are going to be asked to use them, especially in your interviews. So dig into loops, dig into arrays. Remember, big point of arrays, fixed size, right? Once we declare an array, we cannot extend that array. We cannot make it larger. Otherwise, we get that argument out of range exception. Big point of loops, they are iterative. Without the break and continue keywords, they will evaluate every expression in a collection, right?
Can I see that whole code, please?
Absolutely. Feel free if you want to, because we do have to move on, Theo, feel free to take a screenshot.
I just did. Thank you.
Perfect. Perfect. All right. I hope my face wasn't in a weird position or something when you took a screenshot. All right, guys, let's dig in to our next concept. We want to talk about object-oriented thinking. Oh, this is a good assignment for you guys. If you want to screenshot this, please do. If you need help with arrays, want to go ahead and make an array containing your 4 favorite fruits as a string. Iterate through this array and log each fruit to the console, and try to do it with a couple different loops. See how many loops. See if you can do it with each of the 4 loops that we mentioned. And then the last one, adding fruit to the array with array.push, that is JavaScript specific. Ignore that. I wish I could cross this out right now.
I wish I could actually use that in C#.
Yeah, no, that's not how that works. Cross that out. That's not a thing.
But lists are good like that.
Yes, yes, yes. Absolutely. There are other collections in that namespace which will allow for a lot more extended functionality. So cross that out. I can't stress that enough. Array.push, nothing.
Mom, are you sure?
So let's move on to kind of our object-oriented portion of this lecture. We want to talk about object-oriented thinking. And the basis behind object-oriented programming is everything, and it sounds silly, but everything is a thing. We are going to build self-contained units which have attributes and perform actions that can live completely on their own. They will interact with other self-contained units, and it will provide the basis of our program. The best way I can think to describe this is a car. Let's think about a car. A car, while it is one large thing, is built in an object-oriented fashion. There is a motor built which has attributes and performs actions. Those attributes and actions interact with a transmission that has its own attributes and performs action, that interacts with a drive shaft, a rear differential, so on and so forth. Each is its own standalone object, right? So that's the best way I can think to break down object-oriented thinking. But to really get into that, we have to understand the core elements which make up object-oriented programming, and that is classes and objects. And that's what we're going to spend the rest of our time talking about today, is classes and objects. So we have a couple what moments here, right? We want to define a class. A class is a programmer-defined reference type. And an object is a block of memory that's been allocated and configured according to the blueprint or class. This might mean something to someone who's been in the software development world before. This might mean something to someone who's read up on memory allocation. However, this doesn't mean something to most of my students, right? This doesn't make sense. What is a class? A class is the blueprint. A class is the idea. Let's break it down. Car. Theo, I can't tell you, hey Theo, go buy car. Theo, can you go buy car?
Technically, I can, but you're not really being quite definitive in your request.
I disagree. You can't buy car. You could go buy a specific car, probably.
Right.
The idea car it's an idea. It's something that lives in thought, right? It's nothing I can put my hands on and touch. Car is the class. It is the blueprint. It is the overwhelming idea, right?
It's the object.
Yes. No, it is the class.
Oh, the class.
It is the class. But Theo, I can tell you, go outside and put your hands on your car, right? Your
That's the object.
Yeah, your car is the object. Your car exists in physical space. So the difference between class and object is idea versus implementation. It is thought process blueprint versus what exists in physical space. And let's dig into that a little bit. Let's break down a class. A class is made up of 3 elements. There are fields, which is a data member of a class used to store information about the class, and we're going to break that down. That's should be another what moment. There are properties, which is an accessor member used to programmatically get and set data, and there are methods, which are your functional members used to implement any kind of behavior. Theo, did you have something to say? I saw the...
No, it's like LAX during the 7 o'clock morning hour here.
No.
So everybody's going now.
I understand. You saw the size of my family. I get it. So let's break each of these things down. Fields, data member used to store information about the class. Fields are what's going to hold on to your data. Think of fields as your open hands. All they do is hold whatever you place there. They're not responsible for giving out data, for putting the data in the hands. They are just the shelf with a label. Your properties are the actions, the actual implementation of setting data on that shelf and pulling data off that shelf. And then methods are your verbs. They're your actions on the class. An engine, let's think, if an engine is our class, run would be a method, right? Well, provided it's not the engine to my car right now, but the engine to most cars, run would, or my run method would just fail, right? So they are your methods. They're your actual verbs. And we're going to break this down right now. We talked about a car class. Let's go back in our application and let's build it. So we got our sandbox application here. Let's go ahead and create a class. However, we can't do that here, can we? Where are we at right now? We are in a class definition. Classes are not declared internally of other classes. We need to be within the namespace, outside the class definition, and we're going to declare our first class. So we're going to use the access modifier public. We're going to use the class keyword, and we're going to follow the Pascal casing convention for class names and say car. So this car is going to have 3 properties. We're going to say, notice I use the prop quick key. So I say prop tab tab, and I quickly auto implement a property. So we're going to have an int year property. A string make, and a string model property. So let's evaluate what this means. Properties get and set data, right? That's what I just told you. However, I didn't declare anywhere to set that data down, right? If these are truly properties, what did we learn? Properties are only responsible for pulling data off the shelf and putting data on the shelf. Where is the shelf defined? Well, C# does a lot of that for us. It's called implicitly defined fields. So behind the scenes, the year property defines a year field that the year property will set and get data to. And the same thing with make and the same thing with model. I do encourage you guys to take a look into full properties and declaring backing fields. That is something you're going to need to know. But for our lecture today, we're going to use auto-implemented properties and fields. So cool. We have defined the blueprint of what makes a car, which is awesome. This is great. This is great news. However...
Oh, I'm sorry.
No, you're fine. What's up, Rick?
I was going to say that's the one thing I'm not 100% set on, sure on, is the get set. Is that basically so you can just pass variables to and from the class to the methods?
It's so you can pass information into the class. Now, properties and fields define what the class is.
Oh, into the class itself.
Well, into the instance of the class, right?
I got you. Okay.
Yeah. So this is we got to think, remember, let's abstract that thought process. This is just the blueprint. This is the definition, right? The blueprint doesn't do anything.
Right.
In our case, it doesn't do anything here. All it does is define what will exist. Every time I create a car, I know that it will have 3 attributes. It will have a year, a make, and a model, right?
Yeah, I understand that. It's just the get set. The gets, the way you have it is a shortcut for get this dot model equals model, or this dot make equals make, or this dot year equals year, I believe.
I think you're thinking constructors. I think you're a little ahead, which we're going to get to today.
Okay.
But so get set, that's your getter and setter, right? Those getter and setter methods are responsible for setting information on that shelf or storing information in that backing field and then getting the information out of that backing field, right?
Okay.
That is required on a property because that's what a property does. Without that get set, we would have actually have made a field. So if we get rid of get set there, we actually make a field, but there's a different casing convention for fields. If I wanted a field, and this is just real quick. Oops. If I wanted to make a backing field there,
which is usually, the underscores usually denotes for a private.
Yeah. I actually messed that up. Oops. There we go. So that would be the syntax there.
Okay, so without the get set, it becomes a field instead of a property.
Because a getter and setter is what defines a property. It's what makes it a property.
Thank you very much. That cleared up something that was bugging me for a while.
No problem. And then I encourage you look into custom getters and setters,
which I've been working with.
Yeah, you can write
logic
logic
in my head hasn't clicked until now. So
okay, very cool. You can write logic, Rick, as to how that getter works, and you can evaluate the data being put into that getter and say, if it's let's say you have the price of a product, right? You don't want to set the data for price if it's less than 0. We both agree you can't have price less than 0, right? You can have 0, you can have free, but less than 0 doesn't make sense. So you can control the setter, and if the user ever tries to set a value which is less than 0, you can throw an exception.
Gotcha.
Cool. So guys, like we said here, what we have here is the blueprint, right? But this is great. Theo can't go out and buy this, right? We just talked about that. Theo can't go out and purchase the idea that is car. For that, we need an object. We need an instance representation of this class. So in our main method, in our execution entry point method, let's go ahead and make a new object. Oh, question wonder. To make an object, guys, if we create something, much like any of our other data, we have to store it in a variable if we want to reference it later, right? So let's create a variable called myCar, and we are going to create a new instance of car. This is awesome, guys, because this creates an instance of the car class. Now we have something we can touch. Now we have something we can manipulate. We can also set value. You can say myCar dot year equals 2010. myCar dot make equals Volkswagen. myCar.model equals CC. So we can set those values. We can also get those values. We're using our setter when we assign values. We can also get those values. Council.writeLine. And what's the syntax for string build? I think it's
for what?
Year 0.
Oh yeah.
Make
You have to
one
variables outside in commas.
model. I think that's the syntax, right?
Yeah, that's correct.
You're helping me with my project that hands-on unit 15, I think.
Oh yeah? Well, I don't want to do it for you, but it is a pretty good example of.
I was having problems with string building, and this is what I needed to do here.
Okay. Well, make sure you grab a screen snip of this, and before you do, let's evaluate that it works, right? Let's make sure it's not bad code. If you feel free to review, but nope, here we go. 2010 Volkswagen CC, so it does build that string based off of the variable values passed in at the arguments right at the end. Cool. So cool, we have created a blueprint, a class for what a car is, right? And we have now also breathed a car into existence. The joke is all programmers like to play deity, right? So we have created, upon our program we beseech car, named myCar with these values, right? It's a very powerful tool, and it is the core for what you will be doing as an object-oriented C# developer. Guys, if you don't understand this you need to spend some time. You have to get this down. It must be understood, right? Cool. So far, so good. Let's do a quick instance versus object game. All right, I'm going to pick a contestant. I'm going to give you an example of something in space. It will be either an not instance versus object. Oh man, it's class versus object. Class versus object game. I will give you an example of something in space, something that exists or an idea, and you will tell me whether it's an instance or a class. All right, now Lesh, I noticed you're off mute. Are you ready?
Yeah.
All right, I'm gonna spin the wheel, and we got computer. Elish, is computer a class or an instance?
Object. Class or object.
What'd you say, Nalish?
Class.
Very good. Why? Defend that. Do you need some help? Would you like to phone a friend?
Yeah.
Phone one of your classmates. Ask a classmate for help. Nalish, you gotta ask someone for help, man.
Theo?
The best definition I have is an ideal representing a machine with calculating and programming characteristics or abilities.
All right, so that was our programmer definition. I liked that. That was our programmer definition. Let's give Rick a chance. Break that down. Why is computer a class?
Computer is a class because it defines a theoretical instance of something, instead of, if you had like a Mac, that would be a type of computer.
Right. It's an idea. It's nothing. I can't go put my hands on computer, right?
It's ideological.
Yes, I can put my hands on my Dell laptop.
You can't
right?
put your hands on it.
Right. Very good. All right, let's spin the wheel again. Theo, you're next. Let's spin the wheel. All right. I got my coffee cup. Is my coffee cup an instance or a class?
It's not a class. It's more like an object or an instant. I guess an object is an instance then.
Very good. Defend that. Why?
You can actually hold it.
Yeah, that was easy. Very good. And then Rick, finally, monitor.
Monitor. Well, you know what? I can hold a monitor in my hand, but there are different types of monitors.
Mm-hmm.
So it would be it could be both. I mean, you could make a class. I mean,
you could, right? But the monitor itself, what is monitor? Is it closer to an instance or a class?
I'll
give you a hint. You're overthinking it.
Probably.
You are.
That's my problems too.
A monitor is it's an object. It's a class.
I went with class.
Rick, your monitor, right?
Oh, a monitor, yeah.
Your monitor, or a given monitor in space, is an object. It's an instance. However, monitor, the idea, right? The idea of a screen that can display information.
Yeah.
That is a...
I overthought myself.
Yeah, I know. That's all right. All right, good job, guys. Good job.
So verbally speaking, syntax, I guess, if you're trying to describe it, for instance, class program. Class is a program, but you can't put your hands on it. But if it was a program, then that would become an instance.
Yes, a specific program, right,
Right.
is an instance. But the idea program, how many different programs can you think of, right? The idea program application which does something can be used by users theoretically or perform some action in the background, right? That is a program. It can be any number of things.
I'll be right back.
When I'm trying to figure that out, if I use a before the noun, that will help me figure out the object or instance, correct?
Yes, because I would think yes. It's hard to say yes to anything that generic.
Right, right.
It's almost yes because A would signify a specific, right? Something you're pointing at. So,
Yeah. Okay.
all right, guys, cool. We've reached 8 o'clock. We are going to take a 5-minute break. Go ahead, get up, use the restroom, get coffee. I have this cool egg timer that they have at this. I can set it on its side for 5 minutes. It will go off in 5 minutes, and we will resume lecture.
What just happened? Did he leave?
He said he'll be right back in 5 minutes.
Oh, okay. Thank you.
You're welcome.
There we go. You okay, man?
Yeah.
It's talking to me.
Josh,
Yes?
you okay?
Oh, yeah.
Okay, cool.
Why wouldn't I be okay?
I don't know.
No.
I was in the bathroom when
wasn't
you
for me.
took
The
off,
break
and I
was for you
came
guys.
back, and you were gone.
Oh, no, just walking around the office. The break wasn't for me. It was for you guys. I know it gets hard to sit there, right in first in the morning.
Oh, okay.
So, yeah.
Yeah, I just got a text from Amazon saying my package was delivered, and then I looked outside. There was no package. Looked on the site. It says it's still going to be 2 more days. So,
Surprise.
yeah.
All right. Cool. So let's go back and jump back into how. So I've given you guys some information, and everyone can hear me, correct?
Yes.
Do we lose, I believe it was Nilesh, do we lose?
We lost one and picked up one.
All right.
Yeah, looks like it.
So we're going to talk about how did we get here. So I told you guys an object represents this instance, this things we can touch, where a class represents an idea, a thought process, a blueprint. And I've also told you guys that we go from one to the other. Your first question should be, well, how? That doesn't make any sense, right? If I have a blueprint for a hotel on the Vegas Strip, how do I go from blueprint to existing hotel with rooms and beds and guests and stuff like that and employees, right? That should bug you guys. So we want to talk about how we go from A to B, from class to instance. And for that, we need a constructor. Much like our hotel example, we must construct the physical instance. So far, so good?
Mm-hmm.
Yeah. So we are going to learn how to write custom constructors. We say, but what? We just did it. We just went from class to instance, and we wrote no constructor. We don't even know what it is yet. Much like our backing fields, there's an implicitly defined constructor, and it's called via method syntax. A constructor is going to raise another question for you guys. I told you guys classes are made up of 3 pieces and 3 pieces only: fields, properties, and methods. Well, I didn't say constructor in there, did I? No, that's because a constructor is just a type of method, right?
Right.
Building something or creating something is a verb. It's an action. So a constructor would fall into the category of method. Now, constructor can help us configure how we create the instance. And we can actually do some pretty cool logic here. So let's write our first constructor. Our syntax for a constructor in C# is going to be access modifier, in this case public, and then name of the class, car. Well, like every other method, and this is going to get us into method syntax as well, we got to declare any arguments that must be passed. So do we need any parameters? And then a logic block. So far, so good?
Yep.
So let's go ahead. When we build a car, the whole point of building a car in our application is assigning this set of like data, assigning a year, a make, and a model to an instance of an object, right?
Mm-hmm.
So to create a car, to create this grouping of data, we need a year, a make, and a model. So let's go ahead and include those in parameters. So we need a string, int, given year, string, given make, and string, given model. So to create a car, we need to be given a year, a make, and a model as information. Well, what do we want to do? When we create a car, when we bring a car into existence, we want to assign data to the car's year, make, and model property. Well, the data that we want to assign to the year would be the given year, would be the year that we are given. Same with the make. The data that we want to assign to the car's make is the make data that was supplied. So let's go ahead and assign those values. We're going to say year with a capital Y, saying the year property will be equivalent to the given year data passed in to the constructor. The make of the car will be equivalent to the given make data, and the model will be equivalent to the given model. So all
when you
we're doing,
instantiate that class, it's going to populate those. It's going to populate those variables, basically.
right, so the constructor's job is to take us from blueprint to actual thing we can interact with, right? Now to do that, to create a car, we are going to have to supply some information as an int for given year, some information for given make, and some information for given model. So to create a car, if we notice in our application, this is no longer valid, right? Because this is calling the constructor, we must now supply information for those parameters as arguments so that we can assign that information all in one line. It's a very cool tool. Now also, this naming convention seems a little weird, right? Given year, given make, and given model. Seems a little wonky, doesn't it?
Yeah, I guess.
The reason that I did that is to just show the difference, to know that when we refer to capital year, we're referring to the property, right? And given year refers to the data passed at the time of constructor call. So we can go ahead and modify this to just be year. Given make can just be make, and given model can just be model. This will make it a little more convoluted, but now that we see what's going on, this is our general naming convention. Remember, C# is case sensitive. Capital Y year refers to a different element of our program than lowercase y year, while capital Y refers to the property on the car class. Lowercase year refers to the argument passed in place of this parameter. Same thing with make, same thing with model. Now we notice, we can actually quick comment that out, this constructor call is no longer valid, right?
Right.
We must now supply some data. Well, we said we need some integer, some string, and some string. The first integer should represent the year of the car, the first string should represent the make, and the second string should represent the model. So let's supply that information in comma-separated format. 2010 being the year, Volkswagen being the make, and then CC being the model. We have now created a car and used constructor functionality to assign its values to the data passed into the method call. So if we run this, we're going to get the exact same output as before. Whenever it decides to execute, of course. Aha! Success! Good job. So
does that supersede the above class, or is that all part of the class?
It's all part of the class. This is a method that exists on that class, right? So it's part of the car class. It's just, we're no longer using the implicitly defined constructor. We're defining our own explicit constructor, which is very neat because in doing so, we can actually perform any other action at that time. There's time that takes place from going from class to instance, right? So I can perform other logic such as console.writeLine, building car. When I call the constructor, we're going to write building car to the console. Let's run this application, and we'll see it writes building car to the console because the constructor is executed. Then we console log our information. So guys, constructors are a very powerful tool. We need to understand how to go from instance to object, or from class to instance. Why am I messing that up? Cool, guys. Constructors can be
Very
written
cool.
on any class, and they are also written with the method syntax access modifier, but instead of name of method, we want name of class. Very awesome, guys.
Okay.
Let's talk inheritance. And this is the last thing we'll talk today before we let you guys go. So inheritance is passing attributes or functionality from parent to the child. This works just as inheritance does in real life. Right? So let's make another class here. I'm within that class definition. Oops. Let's get out of the car class. Let's make another class. Public class race car. Now a race car is going to have a year, make, and model as well, isn't it?
Yep.
But what else is a race car going to have?
It's gonna have like extra
Let's
attributes.
just say it's got a sponsor, right? Let's focus on that. Let's say it's the,
Okay.
in our theoretical world, a race car is the exact same as my sedan, except it has a sponsor. That's
Okay.
obviously,
Yeah, I got you.
obviously not true, right?
I don't know. I haven't seen your car.
I can tell you it's not true. However, if we were to write public year, public make, public model, what would that do? That would violate dry, right?
Yep.
So we are going to inherit all functionality from car. We're going to get rid of our constructor here. We're not going to go into constructor inheritance. So this is no longer valid. And then that means we need this back. Let's uncomment that. All right. So what we've done here is we've passed attributes. Much like a parent does to a child, we've passed attributes from parent class to child class. The parent class in this example is car. A car has attributes about it, right? Much like our parents had attributes about them that we inherited. However, there's also several unique aspects to us individually that we didn't inherit from our parents that are specific to us as individuals. Much like the race car has the unique attribute sponsor. While a race car will have a year, make, and model property, it will also have a sponsor property. So to show this off, let's not only create a car, let's create var dream car, let's call it, equals new race car. Let's say dream car dot year equals, I don't know. Someone give me a car.
Challenger,
What year?
2016.
2016.
What you drive, Theo?
That's why I'm taking this class. I want that car.
Oh, okay. All right, that makes sense.
Yeah, me too. Me too, Theo. So dream car.year, dream car.make, dream car.model, but also our dream car is a race car. So it's got an additional attribute, doesn't it?
Yep.
Dream car.sponsor. Theo, your dream car is sponsored by Coder Camps.
Sweet.
Cool. So then we could log all this information, but we see the attributes being passed from parent to child. This code will compile and execute perfect. Right? Oh, Nilesh, welcome back. And you're now Nilesh and Avani. Hi. Both of you, I think.
I switched computers, that's why.
Oh, okay. Well,
Yeah.
welcome back. So very, very cool, guys. So we know inheritance can pass functionality, pass attributes from parent to child. It's a very powerful tool. Be sure to really dig into your classes lesson, right? The classes lesson that we go over. If you guys would like exercises about classes and inheritance, feel free to create the animals lesson that I will describe in just a second. But we want to talk about kind of what inheritance does. It's super powerful, but it's also very dangerous. It's very dangerous. It creates tightly coupled relationships between classes. Whereas if I make a change to the car class, that change will be reflected on the race car class, right?
Right.
So we want to be very careful about using inheritance. We can use it. It's very powerful. We want to be careful because now if we inherit along a long chain, anything that changes at the top of that chain will be reflected all the way down.
Because if you inherit from race car inherits from,
Yep.
and so on and so
And
forth.
so on and so forth. Very good, Rick. Very good. It's powerful but dangerous. I challenge you guys to build an application that expresses different animals. Try to express a bird, a monkey, a dog, a cat, whatever it may be. But notice one thing. It's that all of these things share certain traits, right?
Right.
They're all going to have a species. They're all going to have a number of limbs. Even if that number of limbs is 0, they all have a number of limbs. They have a number of eyes, right? There are different attributes that all of these things share. So I would challenge you to use inheritance to try to build an application that would display information about multiple animals. So that's the end of our slide deck. There is a couple more things I'd like to talk about, guys, before I let you guys go. I know we're getting to the end here. Thanks for bearing with us today, guys.
Oh, it's been great.
So I want to talk about a couple of things. The first thing that I want to talk about, let me get through my slideshow, is I want to talk about the concept of algorithms. And that's a very common, I'm going to tilt my screen so I can lean back. I'm going to get my instructor pose and lean back a little bit. It's a very common question we get asked, guys, is algorithms. Okay, and people watch movies and people kind of break into programming, and at first, when you first get in, I want to write an algorithm. Guys, let's not fall in love with the idea that an algorithm is something crazy. There are very complex algorithms, but there are very simple algorithms. And an algorithm, guys, is just steps to solutions, right?
Right.
Problem-solving steps expressed programmatically. Programming algorithms. So much like there's an algorithm there was an algorithm to compute absolute 0, right, and figure out what absolute 0 was. There's also an algorithm to making a peanut butter and jelly sandwich, isn't there? There are sets of steps that need to be taken to be successful. Now,
it's kind of like a formula, pretty much.
Yes, very good. Thinking like an object-oriented programmer, that algorithm consists of different things which have attributes and can perform actions working in harmony, right? Theoretically, to make a peanut butter and jelly sandwich, there's bread. Well, there's a slice of bread. You have to instantiate a slice of bread. You have to create Slice of bread, and then you have to do it again. Theoretically 2 unless it's open face. There's many things you can do. Slice of bread has its own attributes. It does its own things. Over time, it will rot, right? That is action. That is something that will happen. There's also the peanut butter. Peanut butter has actions, has attributes. Jam has attributes, has actions. The charge, the knife, the user. How can I interact with all these objects? What are the steps? What action do I have to perform to scoop peanut butter? That's a very specific action, isn't it? It's
right.
Stick knife in peanut butter, pull knife out, right?
Right.
Very specific steps. So the more intricate the problem and the more deep you need to dive, the more intricate the algorithm. But don't fall in love or infatuation with that phrase, right? It's just a set of steps used to solve a problem. That being said, to get into your industry and to land that first job and to interview properly, you're going to have to know a couple common algorithms and problem-solving steps that have been solved by people before you, right? So you will need to go over algorithms lesson and really dig into each of those and try to understand what they mean, because you will be asked about them.
I like the Gauss algorithm because, that cat was in elementary school and teacher was giving him busy work and he's like, well, I can figure this out with,
right.
sweep.
Yep. That was it was very common when I was growing up. Typing classes were big because everyone finally accepted that computers were going to be a thing. So
right.
You had to teach kids how to type so they could be successful. And
right.
The smart kids just learned how to work with a computer and how to get it to type what you wanted to, especially when you're like, we'll type this sentence 100 times.
Right.
How to get it auto copy pasting and have a script. Those were always the people who knew were going to be programmers. But very, very cool, guys. Finally, I want to talk about two more points. I want to talk about design patterns, right? Another very common topic in our field in object-oriented programming. It's another concept that can be broken down very simply. It's at its core, it's not something very complex. A design pattern is exactly what it sounds like. It's an organizational layout of your application. The idea of abstraction, of pulling different parts out where each part has one job and performs one action is theoretically a design pattern, right? MVC, Model View Controller, which you'll get into when you work with ASP.NET, those are common design patterns, right? All a design pattern is the organization of your logic. How that logic flows from point to point to point in an abstract fashion. So really check out that lesson on design patterns. You guys are going to be asked a lot about design patterns. And finally, unit tests. Guys, unit tests are huge. You're a .NET developer. Unit tests are huge. Dig into unit tests. Unit tests are just taking those pieces of your application and testing them independently, right? If I have an engine, before I ever throw it in my 69 Impala, I put it on the stand with a starter, I press a button, I make sure I got oil pressure, I let it run, right? I check my temperature, I test that piece. I could do the same for a transition or a transmission, the same for a differential, the same for a steering column, right? It's important to test all those pieces independently before they go into the system. Because if you put that engine in and it fails, it could break any number of things, right? It could cause any number of points of chaos throughout the entire system. Unit tests are huge. We want to write our unit tests independent, right? They should stand by themselves. Each of our pieces should stand by themselves, and our unit tests should be able to be executed at any given time to a point of success. We're going to dig into the idea of what is unit testing, really dig into that lesson pretty deep, see what you can pull out, and if you have the chance, try to write some unit tests for yourself. It's a new way of thinking. It's very abstract, but try to get into that.
One thing I have to say on that, I was having problems copying and pasting the lesson. It's if you copy and paste the lesson text from unit testing into your console app, you're going to get all kinds of problems. Anyways, Jason Tennant had made a little video and posted it on the general thread channel, rather. If any of y'all want to look at it, it's there right now.
Okay.
And
I noticed that too.
he put a GitHub link.
The old class gave you the raw data You click raw data and just copy and paste over to Atom or Visual Studio. Xander does do that.
Well, we want to avoid copying and pasting, right? Sorry, I'm making note of the unit test point that you brought up. We want to avoid copying and pasting, right? We want to rebuild and implement in our own way, change variable names. Not only practice our typing, but change variable names, understand the piece, right?
Mm-hmm.
I can watch 400 videos on how to use a wrench. I could read 3 books, right? Until I get in and use that wrench and use it improperly and break it and am forced to fix it, I will never truly understand how to use it. So we want to avoid copying and pasting. I know it's easy to grab this stuff, right? But so we get 4 billion errors, right? Let's read into those. Let's see. Maybe it's on a wrong project. Let's do some Googling, see if we can't come up with a solution. I'm not saying that's your responsibility. I'm making note of this. We're going to talk about that immediately with our.
No, I agree with you 100%. In this case, this was something different.
Right.
It was using directive.
Okay.
It's not available. I mean, there's some issues. I haven't watched the video yet, but maybe it was something stupid. I don't know.
No. And like I said, I'm not talking about this case. I'm just talking about in general.
Okay. But in general, I agree with you 1,000%.
Cool, man. All right, guys. Well, thanks for coming today. Guys, remember, we need to be attending 1 lecture a week. And Raquel, I see you're driving. Do your best to try to be at a desk. If you're going to work, I understand that. I get that. I'm here now. I'll be here till late tonight. Try to get to your desk early. That way you can be at a computer, right? Bring your laptop. You can be at a computer if you can. I understand, people have lives. So thanks for coming out today, guys. Great job, everyone. I'm going to check and validate and make sure we actually got our recording. If we did, I will post it up later this afternoon after it's done processing.
Hey, that sounds great, Josh. Thanks a lot, brother.
Thanks, guys. Hey, have a great day, and good luck with you guys. We'll see you.
And Thursday will be a repeat?
Thursday will be a repeat.
All right. Okay.
Cool, guys. Take it easy.
Ciao.
Bye.